In problem 28, I want to find where these two lines intersect. X plus 2y equals 8, and 3x minus 5y equals negative 7. And ultimately, we want to express our answer as an ordered pair, an xy ordered pair. So since these are lines, we can express them graphically. They're given to us in standard form. To create graphs, we can rewrite them in slope-intercept form. So this first line, I can rearrange it by subtracting x to the other side. So I get 2y equals negative x plus 8. And then dividing by 2 gives me y equals negative 1/2 x plus 4. In a similar way, although the numbers are going to be kind of awkward here, I can do the same thing over here. Solve this one for y. I get negative 5y equals negative 3x minus 7. Dividing by negative 5, I get 3/5 x minus 7/5. Sorry, plus 7/5. So if I graph those two lines, I can get a rough sense of what's going on, but we'll see pretty quickly that it's not gonna look really nice. So I have a positive 4 x-intercept from this first line and a slope of negative 1/2. So it's going to slant downward like this. The x-intercept is going to be over here at 8. With the second line, 7 over 5 equals 1.4. And then we have a positive slope of 3/5. So it's going to climb upward, something like that. But even with a careful sketch, it would be hard to find this intersection point. However, algebraically, we can, with relative ease. It's not going to be super easy, but with relative ease, we can find the exact coordinates of that intersection point. So let's try this out. Let me go back to the standard form equations, and I want to think of these as a system of equations. So I'm going to multiply the first equation by negative 3 to get negative 3x minus 6y equals negative 24. And then I can use the elimination method. I can add these two equations together, and it will cancel out the x's. So if I do that, I get negative 11y equals 31. Negative 31. So the value for y is positive 31 over 11. That's a pretty challenging number to guess from this graph. We found that the y coordinate here is close to 3. 31 over 11 would be the height of that intersection point. To find the horizontal position, I can plug this back into one of the equations. So let me plug it back into this first equation. And I get x plus 2 times 31 over 11 equals 8. So x has to equal 88 over 11 minus 62 over 11, which, doing that subtraction, gives me 26 over 11. So the x coordinate is roughly 26 over 11. So a little bit closer to 2 than to 3. And putting those together into an ordered pair is how I'd like to express my solution. 26 over 11, comma 31 over 11. And just to be extra sure that this is working out the way it should, let's double check with each of these equations. In the first equation, I have 26 over 11 plus 2 times 31 over 11. And that becomes 26 plus 62 over 11, which is 88 over 11, which is equal to 8. So this works for the first equation. In the second equation, I have 3 times 26 over 11 minus 5 times 31 over 11. And those numbers, 3 and 5, they multiply, of course, with the numerator. 26 times 3, of course, is 78 over 11. 5 times 31 is 155 over 11. And if you subtract those, perhaps with the help of a calculator, you'll see you get negative 77 over 11, which is equal to negative 7. So these two values for x and y do in fact satisfy both equations, and they represent the intersection point of those two linear equations.